Yeah, thank you so much for having me. My name's Priya. I'm going to be talking about a preprint that we've put out called Easing into Open Science. And I'm also going to be talking about how coming into open science practices might be a better time than ever before to do this. So who am I? I'm a developmental psychologist with a big, like Alex said, with a big passion for open and reproducible methods. I'm an open and reproducible science enthusiast, but most of all, I'm an anxiety-ridden scientist who is constantly worried about how the decisions I'm making about what I'm doing will affect my research projects, my career, my life, my ability to find a job and have money, all the normal things that everyone's worried about when they're in any job, but in academia as well. And so that's kind of the framework I'm coming from to describe how to get involved in open science practices, but also the worries we might have when doing so. So how did I get involved in open science? So I thought this little comic book sketch explained it a little bit. So, hey Cecilia, what are you doing? Oh, I'm just sitting here pondering my life and my place in the universe. What does it all mean? What motivates me? Have I made the right decisions? I thought you were doing research. These are open questions too. So I think these kind of existential questions a lot of us PhD students have and also just generally in our whole careers, but especially during a PhD. So what do I want to be known for? What do I want to do? What do I kind of want my research to stand for? And so I had this little crisis when I was doing my PhD because I was hearing the hubbub about like the reproducibility crisis and how we don't know whether anything is really true and getting freaked out about that, but then also getting excited about all these new open science practices I was hearing about and how I could get involved in them. But then at the same time, also hearing a lot of kind of backlash against that and worries about how it might negatively affect your career to do these things, or how, you know, they could ruin your ability to publish your research and big scares like that. And so I was kind of back and forth with a lot of these worries, but I ended up just deciding to go all in and commit to doing open science because I thought, if I want to do it properly, and this is what I think properly looks like, and if that means that I can't stay in academia, then that's what it means, which I've heard among a lot of early career researchers as well, which is a shame that we have to think like that, but that's how I thought. And so how did I get involved in this paper? So the Easing into Open Science paper, this was a completely cold collaboration. Umul Kathawala from the University of Minnesota just emailed me out of the blue and said, we want to write this kind of tutorial for graduate students on how to ease into open science, and would you be interested in being a part of it, with her supervisor, Moin Saeed. And so I was super excited to be contacted, and I jumped at the chance to take on another project, but a very exciting project. And so I was working on this during the last year of my PhD. And so that's just kind of to show that you can just kind of reach out to people if you have similar interests and just and start something. So yeah. So open science can sometimes feel like a massive mountain and with loads of obstacles along the way, and really scary, and kind of that you don't know what the right way to go about it is, or the right route, or you don't know if the route you're taking is the quickest one, and things like that. And it's scary because a PhD can also feel like that, because PhDs are really scary and they have a lot of those same things where you're always worrying about not doing it right, and it feels like a massive big task and you're not sure whether you're going to be able to do it. So what we kind of wanted to provide is a roadmap for how to do this, and it's by no means the one way for getting into open science. It's just one route that we've talked about and kind of worked out might be kind of one of the logical ways that you could apply different practices one by one to your research. But that, like I said, that's by no means the only way, and you're welcome to dip in and out of anything that I talk about, and also anything else that you've learned about open science. But in this talk, I also wanted to talk about kind of a bit more of a topical issue. So research right now can feel a bit like this. And I know that people's experiences with regards to like their supervisors are completely different. You know, some supervisors are kind of pushing people to continue with their research maybe as normally as they could do, just with some COVID safe measures. Some people are urging students to push their work online, or maybe even just saying, let's pause this for now and come back to it when we're more able to. And none of these approaches are kind of right or wrong, but it can be really scary to navigate. And so hopefully I'm going to talk a little bit about how these open science practices, but also some other bonus ones that I'm going to talk about at the end, how they might help you right now. So yeah, so those slides will be denoted with this little cute COVID, so you'll know when I'm talking about that. Okay, so let's start with one of the first practices that we're interested in. Oh no, first. So when we talk about the different practices, open science practices that you can get involved in, we're going to talk about what they are, why you might want to engage in any of them, how you can engage in them practically. The how, there's a lot more information in the paper and also in the resources that we pointed you to in the paper. So I won't be able to kind of take each practice and do a step-by-step here, but this is more of a kind of, if you're interested, go explore there. And also worries. So what worries do people have with regards to participating in these practices? But first, it's important to kind of step back and say, what is open science? Because I think even if we have a very avid interest in open science, not everyone has the same definition. And there isn't one right or wrong definition, but I really like this open scholarship umbrella. So open science is sometimes called open research to kind of include subjects that are still research-based but not science, and also open scholarship to include the whole cycle of not just research but teaching as well. And so I love this umbrella. It was originally created by Danielle Robinson and Robin Champion, however you pronounce. Sorry about that, but it's now been adapted by Olivia Guest and Kirsty Whitaker. So it includes a whole breadth of practices, for example, open access, so making sure that your published work is open to anyone, pre-registration, so we'll talk about it more in detail, but basically making your methods and hypotheses specified before you start a project. Open educational materials, so making sure that the stuff that you create to teach others can be open and used by others as well. Open source, so using and producing open source software. Open data, so as much as you're able to, sharing your data openly for others to use. Community science, so including the public in the science that's done. And open notebooks, so keeping a track of and making open all the steps that you took in your research project. And you can see that equity, diversity and inclusion is not one of the many underneath this umbrella, but is actually the thing that is underlying everything. And that's because if science isn't open to everyone, then it's not open science. And there's a great new piece in The Psychologist that Olivia and Kirsty wrote that I've put a link to there. These slides will be on my OSF as well. There was a link at the beginning, but if you just search my name, my OSF, the slides are there. So yeah, the Psychologist article is a very good introduction into that. So why should we do open science in general? So there's all the kind of good Samaritan reasons, which were what motivated me originally. So things like, making sure that that we're honest about the science that we do and that other people see all the honest decisions that were made, to avoid kind of publication bias and just people kind of spinning stories that aren't really what the data show and things like that. And making it easier for people to reproduce our research, making the resources we create, like the materials and our data and our code and things, available so that people can use them for their own work, so that we're not reinventing the wheel. All those good reasons, they're all fantastic reasons. But there are also selfish reasons, which, for example, making your work more organised, making yourself possibly more favourable to reviewers in your work by engaging in these practices. And being able to both share your own stuff but also benefit off the sharing that other people have done. I think even though I've used a devil to illustrate the selfish reasons, there's no shame in thinking selfishly about these kind of things. I mean, not many of us are in a privileged enough position that we don't need to worry about stuff like, will I get a job after this and stuff like that. So it's not a bad thing to think about that. I think sometimes it can be almost too moralistic, and people are kind of looked down on for worrying about their own career progression. And so when we talk about the worries, we will talk about legitimate worries that maybe you might only want to engage in this practice if you do value kind of the moral reason for doing it higher than the risks. but also where maybe the risks are not actually risks and that the worries are unfounded, and where we can make people not worry about things. So talk about both. So how can we do open science? Luckily, there are loads of resources out there because the open science community is amazing and always wanting to share how to do these things. But you can see that that might be almost a bit too amazing, too many things to choose between. And it can feel a bit overwhelming. And sometimes when we have too many options of resources to be able to know what to do, then let's not do anything, especially if we're seeing kind of sources that contradict each other a little bit, and we don't really know enough about the individual thing to know which one is right or which one we want to go with. It can be really stressful and confusing. And so that's why in the paper and in the talk that I'm going to do, we mostly focus on the open science framework, because for most of the behaviours that we're going to talk about, you can do them directly through there. And this doesn't mean that it's the best route for all of those individual behaviours, but it does mean that it's only one software or one place that you need to learn, one tool, and then you can do all these multiple things. So it's a good place to start. And then if you do choose later to move on to something else, you can. So what are the worries about doing open science in general? One is, how do I sell this to my supervisor or advisor? This is a really common one, and quite one of the ones that is more specific to working as a PhD student as opposed to just generally in research. So in the paper, we talk about specific ways that you can talk about each practice with your supervisor, but in general, communication is just key. And if you have the responses that we have shown to the worries, then often those are the worries that your supervisor will have, and then you'll have something to say in response, as opposed to just saying, well, I don't care about the worries, I just want to do it anyway. So hopefully kind of those things together will help you have those conversations. The other worry is, won't it make it harder to publish my research? And the truth is, we just don't know yet. Not enough time has passed, not enough meta research has been done to know whether it makes it harder to publish your research if you do open science practices. But anecdotally, it really doesn't seem to be the case, and it definitely shouldn't be an assumption that it does, because if anything, it could equally be helpful because reviewers see it favourably. So I think as times are changing, this is changing, but we just don't know. So you can't assume that it will make it harder. And the most common one is, what if I get it wrong? And this is a really common worry among everyone, not just ECRs. And the answer is, it's fine if you get it wrong. Like, I mean, when I first started in any of these practices, I did a terrible job, and that's completely okay, because it's a little bit like you get an A for effort at the beginning. Your first version of everything is going to be worse than when you've honed that skill. So it's completely fine to get it wrong, and people will understand if you just say, oh, I said this in my pre-registration, but actually that was silly and I should have said this. Like, there are some people in the open science community who really are like, think that everything needs to be the absolute perfect version of itself to be worth it. But they are definitely in the minority, and I'm definitely not of that way of thinking, and neither are a lot of people. So I wouldn't be put off doing any of them because you feel like you can't do a perfect job. So let's start with the first practice. So this is a journal club, which we've rated as easy. So if you've never been to a journal club before, this is a club where you discuss open science and reproducibility. Usually someone presents a paper, and then it leads a discussion on it. And these can really range in how formal they are. So from the most informal, you can literally just have someone summarising the paper in a couple of sentences, and then everyone just kind of chipping in and discussing. Or you can have someone presenting slides and then have a more formal structured discussion, whatever works for you. And why would you want to do this? So to create a community interested in open science, for a lot of the same reasons that the Riot Club was invented. So to critically engage with your colleagues and find like-minded people who are interested in this. But the journal club portion of it, as opposed to the kind of just discussion part, is to make yourselves accountable for reading. So I know that I have a massive list of open science related papers that I would love to get the time to read. And to be honest, unless I'm going to specifically discuss them, a lot of the time I don't get around to it. So it can be really good for that. So how do you do it? So from the easiest way is just send an email around to your department and kind of say, is anyone interested in this? And then later you could always expand to other departments. But the easiest way I think to do this is to join the Reproducibility Initiative. So this is basically a way of structuring your journal clubs that's almost comes ready-made. So they have resources for the templates for emails you can send out to your colleagues, a whole list of papers you can do, you can cover in your journal club, a list of advice for running these clubs, both in person and online. They have amazing resources, and you can get a free teapot if you join as well. So that lots of reasons to do it through reproducibility if you want to, but also feel free to create your own as well. What are the worries? So always the worries with these things is, oh, I don't have the time, it will take away from my research time. And I think that's because a lot of the time we have such a kind of compartmentalized view of what research is, and we feel like if we're not if we're not analyzing data or collecting data, we're not doing research. And that's just absolutely not true. Reading is fundamental to our research, and you will, a lot of the time, will be able to apply what you learn to your research anyway, so it could make you quicker or do better research. So I don't think you should be thinking that taking time away from research is a bad thing, if that makes sense. So right now, why would it be an even better time to do this? So it can be a way to remotely engage with your colleagues when you might not be seeing them that often. I know that I often miss a lot of human interaction, and it can be a nice way to informally chat to them rather than only chatting to them in stressful situations where you're in a meeting, for example. And the good thing about right now is that you could join a remote journal club first to see what it's like, and then use that to create your own one. So at the bottom, you can see that I've put the calendar of reproducibility events that they have there. So you can just go and attend any of those and see what the format's like, and then that could be your first way of kind of working out how to make your own. And then if you do decide that you want to make your own, there's loads of advice down there as well for how to make remote work for you, how to attend and host online. And you'll have to think about different things like, will the person presenting have slides? Will you have structured or unstructured discussion? How will people raise their hand? Do you want a document where people can write thoughts and questions during the thing? So yeah, lots of things to think about, but lots of advice and resources for how to do it. So the next one we've got is project workflow, which we've also classed as easy. So this is all about how you organise your project. So it might not actually seem like it's about open science from the outset, because it's about stuff like your folder structure, naming conventions, version control, cloud storage, things like that, and who has access. And it's the who has access part that makes it open sciencey, because the idea is that if you make this really good project workflow that's really easy to understand, then it will make it so easy if you do want to make that completely open at some point. So why is this good? It keeps you organised. It enhances reproducibility. So if anyone wants to rerun anything you've done, they would know where to get the things they need. It minimises mistakes, because if you've made it open to, let's say, at least your colleagues, then they can check what you've done rather than not understand any of it and just take your word for it. It facilitates collaboration, because it's easy for other people to just jump into the project. Let's say you add a new collaborator. You don't need to send them individual files with long emails explaining what everything is. You might just have a README and everything is really well organised, so they can just get into it. So how do you organise your project workflow? So one way, like I said at the beginning, not necessarily the best way, but one way is to do it on the OSF. So what you can do is you can make OSF works from as private as you want to as public as you want. So you can make an initially private project, then you can choose to add your collaborators if you wish. Then you can choose to have, just a link that they can only see it if they have the link. Then you can choose to make it completely public, anything that you want. And the good thing about the OSF is you can link it with other cloud storage providers. So this is good because you can edit within them directly. So as far as I know, OSF doesn't currently have the feature where you can edit documents and it will save as you go. It does have version control in that you can upload new versions, but you can't edit directly. So maybe if you link something like OneDrive or Google Drive, then you can edit directly, and it doesn't mean uploading different versions. So whatever works better for you. So this is kind of what it would look like. Just have a look around the OSF and look at projects that exist if you ever want to get an idea, and see what it's like. So you just have like the different, you have like a description at the top, and then any tags you want, and then all the files that you want to add, which could be direct. In this one, it's directly in the OSF, or you could have it with a linked cloud storage. So there's loads of good guides on the OSF for how to set up a good project. So yeah, lots of stuff out there if you want to do that. What are people's worries? So the main worry is around the public part, so it's scary to make everything public, but you absolutely don't have any pressure to do this until you feel comfortable to do so. Like I said, this is currently a private project. You can see that it says make public at the top. That means that it's not public yet. So you don't have to do it until you feel comfortable. And the good thing is that by making your workflow really good and by making everything really organized, it will make you more confident to make it public, because one of the worries with making it public is that people are going to think it's terribly organized or not understand everything, or yeah. So if you make it really good, you almost don't feel that fear about sharing it as much. And right now it can be even more important to have a good project workflow, because, you know, I'm sure you noticed if you had stuff on your work desktop at home when all of this started and then you couldn't access it, that's really stressful. So this way you have access to everything, everything's online. You have a way to share large files with collaborators, a way to write together in one document. Generally, like remote collaboration is just so much better if you have a good workflow. And also, it sounds scary to say, but if everyone knows where everything is, then if someone's sick, it doesn't hold stuff up. I know that sounds really like not caring about people's well-being and just being like, make the project go on, but it can be stressful even if you've just got a cold or something, worrying that other people can't continue without you kind of doing your part. So if you have everything together in one place, then it can make it a lot easier for other people to just get on with it. Okay, so preprints we've also classed as easy. So this is an author formatted version of a manuscript. So it's openly accessible, and it can be either instead of publication. So if it's something that you don't want to publish, it could be before. So before it's been officially published, but you do plan to submit it, or it can be after publication, where you just submit the Word document version that was accepted of the manuscript as a preprint. Let's say if you couldn't pay open access fees for the journal, then this way you've still got an open access version. So, like I said, this is a way of making available stuff that you might not want to publish. It means that you can get more feedback and exposure for your paper, because you can kind of be getting feedback while you're also having it under review in an actual journal, for example. And then you are kind of getting more people have access to it at the beginning. You're getting more ideas that you can incorporate into the revision. And you're also kind of sharing it when you're excited about it. Because I know a lot of the time, once you're actually got the final version, last hurdle being published, sometimes you just don't even really care about the project anymore because it's been such a painful road. So yeah, when you're first really excited about it, that can be a good time to share it and get feedback. And yeah, like I said, it can make your paper open access regardless of the journal that you publish in. So you usually can do this through a preprint server. So there's usually specific ones for each field of research. There's SciArchive for psychology. You can also do it directly through the OSF if you don't want it to be kind of specific to a group. And you can link it with your OSF project. So if you have a project like we described before, that has things like materials, data, code, then you can link it with this, and then everything's in one place. You choose a license for it. I would recommend a CC BY license, which just means that people can use it, but they have to attribute it to you. And Moyne's blog on preprints is really helpful for kind of how to do it and what you might want to include in your front page of your preprint and stuff like that. So this is what it will just look like. This is the preprint for the paper that I'm talking about. So it's just there, literally a Word document, and then you can just download it and see if there's a linked project and stuff like that. People worry that by submitting a preprint, they won't be able to submit to a journal. This is usually a completely unfounded worry. Most of the time you can, but there's a good website called Sherpa Romeo where you can basically check for a specific journal, or maybe loads of journals if you're not sure what journal you're going to submit to. Check what their rules are regarding preprints, but most of the time, if it's the author formatted version, it's completely fine. That just means not the PDF version that the journal actually ends up publishing. One worry that I had was that citations will be spread between the preprint and the final paper. But the good thing is you can merge these in Google Scholar, and I think Moyne talks about that in his blog as well. And so that was one of the main things that was holding me back. So that's a good thing to know. So right now, preprints can be good because if you're unable to collect new data, you can still put stuff out there, even if maybe there's not enough for a whole paper. So let's say you run a pilot study, you could put that up as preprint, get people's feedback on it before you make kind of the final version. If you have like a failed study where you did something wrong with the method, then you could publish that as a preprint, as almost like, don't do this, don't make the same mistake I made kind of thing. You could publish your thesis as a preprint if there's not already kind of a way of publishing your thesis through your university. It's also a good way to get feedback when you're unable to do this informally. Like in the normal lifetime, we were able to just chat to colleagues at work or chat to people at conferences and get their feedback on work that we were doing. But now we can't really do that, so it can be a good way to put your work out there and get feedback on it. And another thing is, if you, let's say you're writing a cool methods paper about some good way of doing research that would be really helpful right now, but you know that the post going through all the rigmarole of publication will take months and months, but people really need to see this now because it will be really helpful to their research remotely or something like that, then you can just publish it as preprint and then people have access to it when they need it, and not after peer review. So that's good. Okay, so reproducible code we've said is medium difficulty. So this is basically code for your analyses and data visualizations, and it allows others and yourself to rerun the analyses that you've done and generate the same output. Why would you do this? One thing is it's easy to modify. So let's say you have a really similar analysis you want to do on a different data set. You can just take that code and edit it rather than starting from scratch. It can make it easier to detect errors, especially when you're able to share that code with others, or even just reading through it yourself. As a sanity check, you can kind of think, yeah, that doesn't make sense, as opposed to if you've just point and clicked and not paid attention, you might have made a mistake clicking and not realised. And also it enables you to share it with others for them to check your work and to do their own work with the same code. So this how to do it varies in codiness, which is a word that I would like to trademark. If you're using point and click software, like something like SPSS, then you can just do what you'd normally do and then save the syntax that it produces. So if you think about it, obviously we're doing all these computations on a computer, there is going to be code behind it. It's just that if you're using point and click software, you usually just ignore that. But that code can be really valuable because then you can rerun it. But if you're using a software where you code directly yourself, then you can just save that code, which I'd assume you'd do anyway, but just make sure that you annotate it so that other people can actually understand what you've done and what packages will be needed and why and things like that. So this is just the silly beginning part of the code, but this is like me just uploading my code as a document to, along with the data to one of my OSF projects. So it's literally as simple as that, and then if someone wants to download that, they can, and then either adapt it for their own work or they can run it with my data to check my analyses. So one of the worries is that it's too time consuming, and this is usually for the writing code as opposed to it's not time consuming to save the syntax from a point and click software, because that is literally a couple of seconds, so I don't think you can really use that argument for that. For writing code, yes, it can take a time to do it and make sure it's readable to others. But if you're trying to make it readable to others, that's also you in a couple of months, because you are not going to remember what you did. So it's as much for yourself as anyone else, and it will stop you having to rewrite everything or rerun everything. And another worry that people have is that there's a steep learning curve for certain software, for example, R. And it is true, it is hard to learn coding software, but there's loads of really good resources out there, some of which we've pointed out in our paper and the OSF project that we have. And you don't have to start from scratch on a new software. You can, like I said, you can use whatever you're using already, but just make sure that you're saving the code. And also during your PhD, it's maybe one of the best times to learn new software, because even though it's scary, you're only going to have more kind of requirements later. So I know that sounds scary, but it is a good time to learn it if you want to, but there's no pressure to. So right now, it's a good time to use reproducible code, because if you're unable to sit down with your supervisor and show them your analyses and rerun stuff with them, it can be easier to just send them your script and let them run it themselves. It can also be good because everything's remote now. You can find a coding buddy, even if there's no one in your lab. You could just reach out online and see if there's someone who'd be willing to kind of check each other's code and ask each other questions and bang your head against walls together. And also there's loads of online coding communities, like for R, there's R Ladies and Tidy Tuesday. I'm sure there's lots of others for other communities. So you can get kind of involved in them now that everything's online anyway, and expand your skills. Okay, So sharing data we've also classed as medium. So this is making your data openly available, anonymized data I should say, and having it either in a repository ready for anyone to use, or have a formal system for requesting data. And a formal system is not just saying data are available on request, because we know that that just doesn't seem to work, and then you have to dredge everything up from scratch, and you probably haven't got it organized well, and it's not the best way of doing it. If you have a formal system of how data can be requested, then you know that you have to kind of have it ready to go at any time, or if it's just open and ready. It's best to share your data with the code so that analyses can be reproduced, but that's not to say that you can't share the data by itself. If you don't want to share your code, that's okay as well, because people can at least check things themselves. They could, check, just look at the data visually, or check the means and things, or they could run their own analyses on it. So that's still helpful. So yeah, why would you do this? One thing is for quality and accuracy checks, so other people can, check you've inputted things right, or that you if it's with code, that your code runs on the data. Others can expand on analyses, run new things with your data that they want to answer. It also makes it easier to include your data in meta-analyses. I'm running a meta-analysis at the moment, and I have been appalled at how difficult it is to find the information that I need to find. And the few times where people have shared their data, it's been super helpful, because often they haven't run they haven't done the analysis the way that I would need it to be in the paper to extract what I need. But when I have the data, it's completely easy to do that. So that's been really helpful. And also, I know it sounds silly, but it just kind of signals your commitment to transparency. So it's almost like saying I have nothing to hide, which we shouldn't have to say, but it is nice, because it just means that people know that they could check something if they wanted to. There isn't all this kind of whispering that you sometimes get in journal clubs of, oh, I bet they hid this, or, if you ran this analysis, it would say blah, blah, blah. Well, you're open to check it if you want to, and, make your own conclusions from that. So how do you share your data? So it's best to make plans before the study begins, because even if you only might want to share, but you're not sure that you will, this is because you can then include it in your consent forms that you're asking whether the data can be shared. And there's lots of examples online for how to kind of phrase that and stuff. But it is possible to check, even if you haven't asked about it, to check what's possible. So at my own institution, I actually asked the data management team whether I was allowed to share data from something that we hadn't explicitly asked before. And they said that it's completely fine as long as it's anonymized data. So different institutions might have different kind of approaches to it. It's worth just checking and not assuming that you can't because you didn't think about it before. But yeah, it is worth, even if you're just thinking about it, to put that in the consent form just for peace of mind. So this just literally looks like, again, this is on my OSF project, so you would literally just have the data uploaded. In this one, I uploaded it by participant, which is a terrible way of doing it, but you can do it any way that is easiest for you. And what are the worries? So one worry is that other researchers will almost scoop you and use your data to answer new questions and then profit off your data. One answer to that is yes, like that's a good thing. That is kind of the point, is that other people will be able to use your data. But like I said at the beginning, completely understandable to be worried about career progression and stuff like that. And if you do have some other papers in mind for the data and you don't want someone else to do them before you get a chance, you can just wait until you're kind of done with the data to upload it. That is possible as well. But in general, I would just say don't be scared of that because it's a good thing. Another worry is not getting credit. So again, if you apply a CC BY license, which can be to the whole project, or you can just come and write it in the information about the project or something like that, then people have to credit you if they use your data. So you don't need to worry about not getting credit. Okay. So right now, sharing data is a good thing you could do as a good Samaritan to enable people who maybe can't collect data right now to use your data to answer new questions. But it can also be good for if you have any projects that had to be abandoned, for example, you were halfway through data collection and now you have to submit your thesis. You can share what you've got already, and maybe it's not enough for a whole paper, maybe it's not enough to answer your questions, but maybe it could be included in a meta-analysis later, like I was talking about. You can also, even if you haven't shared your own data, you can search the OSF for existing data sets that you could use to answer new questions or to help you work out best ways of sharing your data, kind of what works when you have a look at it versus what doesn't work, and how that could help you structure your own data when you share it. Okay, so the next one is transparent manuscript writing. So this is, I think this was medium as well, but I forgot to put it. This is following guidelines and standards to how you're writing your papers, so that nothing is hidden. So any stats that you did and then didn't use in the end for kind of your main analysis are still reported. Your decisions are justified, for example, exclusion criteria, your stopping rules, stuff like that. So why would you want to do this? It's helpful for understanding your work and its implications. So if you ran 10 analyses and one came out significant, it's important that people know that so that they can interpret your work in that context. It can also speed up peer review because they won't need to ask for things. You know, they might say, oh, why did you do this analysis? I think this analysis would be better. But if you justified why you did that analysis, they might not even need to ask. It also enables replication because you're describing everything about how you did it that people could then do. I've definitely been on the bad end of this where the manuscript isn't transparent enough and I've interpreted things wrong and then not been able to replicate how the stimuli were made. So yeah, it's really important to do this. So there's lots of guidelines out there, and these are some examples, and we link to others, I think, in the OSF report in our paper. And there's specific ones for specific types of research, like qualitative. So an example would be something like 7 further infants were tested but not included due to experimental error. We see that a lot, so that's good things to keep in. And also stuff like we performed this analysis and results can be found in our supplementary materials. Maybe you just performed it to kind of explore the data, but you're not making any big conclusions from it, but you're still saying that you did it and providing that. So people worry that it will take too long to write manuscripts like this, but if you're logging your decisions as you go, which you should be doing, then it's not like you have to think about this all at the end. It's more like you've just kept track of what you're doing. It's not going to take any longer. It's just that you know that that's how you did it. People worry that it will take up too many words. It's okay for this not to be within the body of the manuscript itself. You can link to a document and just have that on your OSF project, for example, or submitted with the paper as supplementary materials that has additional like detailed methods or something like that, so it doesn't have to be within the actual manuscript. People also worry that it's embarrassing, like to admit that you, for example, in my case, when I did my first infant study, I kept rescheduling babies that couldn't come in, and then they ended up being too old for my age bracket, so I couldn't include them. And I should have just not booked them in, but I just didn't think about it, and so I had a much larger number of like infants that weren't used then that I should have. But you just need to be honest about it because, you know, we're all human and we all make mistakes, and that's okay, and it shows that we're trustworthy if we're open about these kind of things, rather than otherwise people just read the paper in a very suspicious way anyway. So if you're open about these kind of things, everything else is kind of looked upon in a trustworthy way, if that makes sense. Okay, so right now, it's okay to show how recent happenings have disrupted our research. You just need to be honest about it. So if your sample size was smaller than you expected and you didn't get to test more participants, that's okay. You can just say that. If you didn't get to use a method that you were meant to and had to use something instead, that's okay as well. So you justifying decisions for practical reasons instead of scientific reasons is completely okay. You don't need to make up another reason. You can just say it, especially right now. Everyone knows that our research has been completely disrupted. And that's okay, and we just need to be open about that. And I'm sure we'll see a lot of papers out around about now that are written like that. Okay, I need to whiz through now. So pre-registration, also medium. This is posting a time-stamped outline of your research questions, your hypotheses, your method, and your analysis plan. And so why we do this is to clarify when things happen. So this is to avoid two things. To avoid hypothesizing after the results are known. So if you know that your research questions and hypotheses were those before you started, no one can later say, oh, you just said that because that's how the data turned out. And you can't trick yourself by saying that you hypothesized something else because it's written down. Another thing it does is avoid key hacking. So if you've written out the methods and analysis plan, again, no one can say, oh, I bet you ran 5 analyses and then this was the one that turned out right. No, you can show that that's the one that you plan to do. And for yourself, you can show yourself that that's the one you plan to do, to not confuse yourself into key hacking. There's loads of OSF templates that make this really easy. Some of the simplest ones are the as predicted one is just a few questions on your methods and hypotheses. The OSF standard pre-reg is also good. I've used both of those. But in general, pre-registrations are very variable. They can be so many various levels of specificity. So it can be just your hypotheses and methods. They can also include stuff like your materials, your decision tree, your code, things like that. And the rule of thumb that I go by, but completely is not the rule for everyone, is I just upload everything that I do genuinely know before. I don't tend to delay projects purposefully in order to write all my code or anything. I might move on to that now that I've kind of got this down, but at the moment I don't. But I will have all my materials ready because I'm ready to test. So I'll upload them to the OSF project that's associated with the pre-registration and things like that. So it will just, this is what the pre-registration will look like when it's filled out. So there's different questions and you just answer them basically. And then it gives, when you're ready, you timestamp that and it says that you kind of decided that at that time. People worry that this stifles creativity or limits exploration, but you can still explore. You just need to be clear that that part is exploration and that's what this will enable you to do. There's no reason, you can do everything that you'd already want to do with your data. You just need to make clear what had been decided before versus what had been decided after. Other people worry that you won't be able to deviate if you make mistakes. Again, I've made loads of mistakes in my pre-registrations. You can deviate, just be honest about why. You can say that was a typo. You can say, I said this analysis, but actually then at this month, I realized this analysis was better. You can even do another pre-registration at that point if you want. Just be honest about everything. And so in these times, because you would have to make all these decisions at some point, and you're just front loading that work to the beginning of the project rather than as you go. If you've had to pause in-person testing, for example, this could be a really good time to pre-register your study because you're not in as much of a rush to start testing necessarily. And you can always do more if you've still got extra time. So like, let's say you think you might be able to test in a month and then you've done your normal pre-registration form and then it gets delayed further, then you can write a decision tree, then you can prepare your code. So it enables you to like keep working on the project and then the only thing that's left is the testing, if that makes sense. Okay, so then register reports, which is hard, follows on from this. So this is papers that are reviewed before data collection. So if they're accepted, the full version after data collection is published. And the acceptance is based on the quality of the design, not the results themselves. And this is really good because it reduces publication bias. So reviewers and editors can't decide to publish your paper based on the results. They have to just, because they're not there yet, they have to evaluate the methods. You have guaranteed publication, so once you actually have got acceptance of the paper, conducting the study isn't risky anymore because you know that it will result in a paper. And it can lead to a stronger design because the review process, the reviewers actually have a chance to input in the design before it's too late, and so you can get a really strong design by working with them. So it works like this: you develop your idea, you design your study, it's then reviewed, and then if you get in principle acceptance, then you collect and analyse your data, write the report, and then it's reviewed again just to make sure that you did what you said you would, and then published. So it's really important to work out your timeline and whether it's feasible for you to do a registered report. You can even, if you find a journal in your field that offers registered reports, you can then contact them and ask about the kind of timeline that you'd be looking at to see whether it would be feasible. There's loads of really good resources on the Centre for Open Science website, and if you combine these with the specific journal requirements for the journal that you've chosen to submit to, then together you've got a really good chance as long as you stick to both of those things. People worry that it will take too long, but the entire project from design to publication will likely take less long than the normal project. But like I said, you just need to make sure that the time when you would be testing makes sense. So if you can only test right now, it doesn't make sense to do a registered report. If you can wait and do all of this writing at the beginning, then it's fine because you can just wait, and then when you get it accepted, then you can collect data. And this can be a really good venue for studies when you can't collect data in person. And it's a good alternative to adapt if you're trying to choose between waiting to do your research in a normal way or adapting your research to how you could test now. For example, if your research wouldn't make sense online, or if the measures to make everything safe would really disrupt your research, then this can be a good alternative because it means that when you test, you can hit the ground running. And right now, when you can't, you can get as much done as you can. So it can be really good right now. Okay, I don't know if I have time for these bonuses right now, but I'll just kind of highlight them in the slides with the on my OSF. So Other things you could be doing right now if you can't collect data, one thing is systematic reviews, because they don't require you to collect new data. You could also be writing theoretical or methodological papers that you might be thinking about. They don't require new data. And you can also be doing secondary data analysis on data that already exists. But those are just some ideas if you're not able to collect data right now. So I hope once you've read our paper, it's useful for easing into open science. Right now, I hope I've convinced you that right now might be a better time than ever to get involved. But we're very open to your opinions, so let us know if there's anything you think needs changing. Our paper's still under review. And so I'd like to say thanks to my collaborators, to the reviewers, some of which were anonymous and some which weren't, and to Open Science Twitter for teaching me everything I know, and to you for listening. Thank you.
Thank you, Priya. We're just going to move on to the Q&A question now. So we've actually had a lot of really great engagement, both in the Q&A section and as well as on Twitter. So thank you so much for a wonderful talk. So I'm going to go through some of the questions. We'll see how many we have time to answer, but I'm going to go through them based on how many people upvoted them. So the most upvoted question is from someone who asked, how did you ease into open science? What mistakes did you make that you learned a lot from?
Good question. So because I was interested in, because I found out about all open science stuff at the beginning of my PhD, I had the chance where I hadn't started any projects yet. So with the first thing I did, I think, was a pre-registration, because I was starting my project from scratch, so it seemed like a good time. And that was the pre-registration that was really badly written. I made like the most stupid mistakes, like literally saying that it would be repeated measures when it wasn't, or vice versa, like really obvious mistakes just because I was like stressed and in a rush and not knowing how to do it. And then I had a really positive experience with that when I came to publish the paper. The reviewers were really kind of excited that I'd done a pre-reg, and I did definitely get, like I said, like an A for effort. And I'm not saying that you should just get credit for kind of throwing together anything, but I do think that when you're getting started, it is okay to just do a worse job than you would be able to do later.
That's a really good point. And I do think PhDs are, training experiences in themselves. So it's probably the best time to try and learn these practices. Okay, so the next question, it's a bit of a long one. So from Anonymous, they say, would you recommend publishing even messy code, particularly if you're learning a coding language while writing the code for your paper? It can end up being very long-winded or done in less efficient ways than someone experienced. But going back and changing it might take just as long as writing it in the first place, and at the end of an analysis, you lose the will to do that. What would you recommend in this situation?
I would 100% advocate for upload that messy code. The thing is, all my code is terrible, very long. There would be like a million easier ways to do it. So many unnecessary for loops, like it's terrible. But I think the most important thing is it can be terrible in that way, but just make sure it's annotated and clear. Because in some ways, long code can be helpful if at every line you've explained what it does, and it can help you think through it and it can help others think through it. So I think if you've done that, no need to go. I mean, I do clean it up in that, like, I make the names for stuff make sense, as opposed I might have just said data 5 or something. So I make things understandable and make sense in that way, but I don't change the kind of structural logic of the code. I agree, that would be insane and take so much time.
Lovely, thank you. So we have two questions about preprints. So one is regarding preprints being edited, that this not affect papers that have referenced them already?
That's a good point. Yeah, I completely agree, because even though we've said that you can merge them, what does that really mean if the versions weren't exactly the same? That's a really good point. And I think there is an ethical issue there almost, in that, like, if it changes a lot after review, you could be citing it to make a point that then wasn't made eventually. So I don't know the answer to that, and it's a really good point, and I think something that we need to work on making a solution for.
Brilliant, thank you. And the second question regarding preprints is from Sam Westwood. So he said the good and bad thing about preprints is that you can go back and revise what you have published. Since the publication of your preprint, is there anything you would change or modify in light of conversations you have had with colleagues or from social media?
Yeah, definitely. I think we've already edited it once based on an informal peer review that we got through email and a couple of other responses we've had. And then, but I think because it has version control, someone could go through, there is that transparency, and no matter how much it changes, someone could see the versions that you have, that you know, they could see where it started. And yeah, we're definitely planning on changing it in response to the different reviews that we've got. Yeah.
Perfect. Sam also wanted to know whether you still see Birmingham as being up north.
No, not anymore. I'm a good northern lass now, and I understand.
Okay, so let's see what other questions have been upvoted. So someone has asked, let me find it. I think one issue with sharing data is that it needs very, very good and complete documentation to accompany it. And I don't think many researchers pay attention to this. I have a terrible time getting basic information on data sets, even from people in my department.
I think that is a massive issue. One thing I have found, though, is that in practice, I do think that having like a really detailed codebook is the best way that you can do it, especially if you have complex data. But for example, when I've been doing this meta-analysis, the few times that data has been shared, there's been no codebook. It's literally just been like a CSV file. And I've managed to find exactly what I needed because it was just simple data. It was just like, the heading was the DV heading, and it was in units that made sense. So I was like, yeah, that's what I'm looking for. You know, you can do stuff like calculate things that are reported in the paper to make sure it matches up so that your thinking is the same as what the truth is. But yeah, I completely agree. And I think that in best practice would be to create a really detailed codebook, but I don't think that should hold people back from sharing their data, because I think that even if you're sharing it and then someone has a problem, they can email you and say, oh, I need this. And then it will teach you something that you'll learn for the future and be like, oh yeah, I should have included that in the next one. It's a learning curve, as opposed to if you share nothing until you're perfect, you're never going to share anything.
Perfect. That was a really good answer. Okay, so I think this is probably a really helpful question for everyone listening. So someone said, this talk is very helpful and I'm looking forward to reading the preprint. I'm working in an interdisciplinary field and prospective students may have never heard of open science before working with me. Can you recommend a very basic resource, ideally in video format or very short paper or blog post, that describes the origin and reasons for the open science movement in psychology?
I think the introduction of our preprint has some really good resources like that. I think I'm like struggling now because I'm like, you know, when you're stressed and you're like, literature. So like, yeah, I'm stressed. I think the Sophia Cruel et al. One is a really good like annotated reading list for open science. So that's a really good place to start, I think. And then both their annotated reading list plus our introduction section will have a lot of good papers. In terms of video things to watch, I mean, loads of the Riot talks have been really helpful and they're all on YouTube, aren't they? So I think you could probably find one in there that's a bit more like the reasons why we need open science. There's lots of recorded stuff in there.
Yeah, thank you. That's actually something I wanted to add now as well. So we've recently divided the videos in the Riot Science Club YouTube page into categories, and one of the categories is like Intro to Open Science. So it has information on why we're doing this, as well as sort of more basic steps on how to do it. So that would probably be helpful as well. Let me just see if we have any more questions. I think we have a few more minutes. Yes, so one last question. That's probably all we have time for. It's from Jenny Murphy. So Jenny said, would a pre-registration not be a better option than a preprint to prevent any questionable research practices for confirmatory research? The proposed research and analysis could be reviewed by others at this early stage, rather than waiting until data is collected and analyzed compared to a preprint. There is also the advantage of the timestamp. What is the benefit of a preprint then over a pre-registration?
I think I see what you're getting at. I think a preprint has a timestamp as well. So the difference is more in whether do you want your methods reviewed, in which case, I guess, yeah, you could just do a pre-registration, make it. But the thing is, the pre-registration is meant to be the version that you kind of do. So if you wanted feedback on it, you would then have to do another pre-registration, which wouldn't be bad, but it's not necessarily what it's intended for, if that makes sense. But there's nothing to stop you, I guess, doing a preprint that was in the format of a pre-registration, like rather than being prose, being more like questions and answers. And that could be a cool way of doing it, because then you could get feedback on your pre-registration and then use that to work out what you really wanted to do, and then go and do the real pre-registration with the answers to the questions that you'd crowdsource feedback on. That could be a way of doing it. I don't know if people are doing that at all, but yeah, definitely something to think about.
Yeah, and I guess obviously the more formal response to that is the registered report, which is aimed specifically for you to get feedback on the kind of introduction and methodology before you do data collection. Yeah. Okay, Priya, thank you so much for your talk today. It was really, really interesting, and I know everyone's going to be really excited to watch it on YouTube if they haven't been able to be here today. So just before we're heading off, I just wanted to remind you that we have Dr. Julia Rohrer's talk next week with an intro to multiverse analysis, which is at the usual time. And if you've missed the beginning of this talk, we also have a workshop for improving your workflow for reproducible science, which is going to be in November. So you can find those details on our website. And lastly, if you're enjoying our content, do show us some love by subscribing to our YouTube page and following us on Twitter. And thank you so much, everyone.